Let z1 and z2 be the roots of the following equation. Question A, using the quadratic formula, shows that roots are. So since it is given that we should use the quadratic formula, and we can see that it looks like a usual quadratic equation with respect to z. So discriminant is what? B squared. It's what? Negative, so it will be positive, so we can write 2 minus 2i squared minus 4ac. 4a is 2, c is negative 5i, so plus 5i, and let expand, so it becomes what? 4 minus 2 times 2 times 2, so it's minus 8i plus 4 I squared, or negative 4, and plus 40i. So you can see that it becomes what? 32i. And then roots are negative b, so it's 2 minus 2i plus minus root of d, so it's root of 32i over 2a, so it's over 4. Over 4. And if we split it, we get into two fractions, we get that 1 minus I over 2 plus minus a root of 32, it's root of 16 times root of 2, and root of 16 is 4, so it's root of 2i. As required. Question B. Express each of z1 and z2 in the form a plus ib, and you can see that this root of I is a problem, and we should get rid of this. And how to do that? We need root of I. What is it? So we can consider complex number. It's another z, just notation of a complex number. Z squared is I, and hence z, roots of this equation, is square root of y, as required. And how to solve such equations? The first step is this complex number should be rewritten in the Euler's form. And what is I? I, it's distance from origin, it's 1, modulus is 1, and argument angle is what? 90 degrees of pi over 2, so it becomes 1 e to the power I pi over 2, and roots are zk, since it's n is 2, so squared, so it becomes square root of the modulus of 1 e to the power of I theta k, where theta k is our angle argument, it's pi over 2 divided by n, it's 2, so pi over 4 plus 2 pi k divided by n, it's 2, so just plus pi k. So, and since it's squared, there are two roots, and z0 is just 1, it's square root of 1 is 1, e to the power of I theta 0, it's pi over 4, which is what? Using formula that r e to the power of I theta, it's what? R cosine theta plus I sine theta, it becomes what? Just cosine of pi over 4 plus I sine of pi over 4. Pi over 4, it's what, 45 degrees, and sine cosine are equal to what, root 2 over 2, so it becomes root 2 over 2 plus I root 2 over 2. And then Z1, and it becomes 1 e to the power of I pi over 4 plus pi plus pi, and it becomes cosine of pi plus pi over 4 plus I sine of pi plus pi over 4. And cosine of pi plus pi over 4 is the third quadrant, cosine is negative, and pi plus pi over 4, it's cosine, just cosine of pi over 4. And sine, it's the third quadrant, sine is negative, and the same as sine just of pi over 4. And it's negative root 2 over 2 minus I root 2 over 2. I start with 0, if you start with 1, so if you consider 1, 2, you get just the 2 to be this solution, but rotated by full revolution by 2 pi. And you remember that you always can add or subtract any number of full revolutions for sine, cosine to get an equivalent. And hence we get that our roots, Z1, 2, now it's these roots are a half minus I over 2 plus minus root 2 times root I, and you can see that root I, it's plus minus, it's a half minus I over 2 plus minus root 2, and root of I, you can see that difference, it's only in a sign, so you can see that it's plus minus root 2 over 2 plus I root 2 over 2. And in general, there are 4 possible combinations: plus, 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 minus, minus, plus, minus, minus, but 2 of them will be equal, and there will be only 2 different solutions, and eventually it becomes like this: plus minus root 2 times root 2 over 2 plus I root 2 over 2. And hence 1 root becomes 1 over 2 minus I over 2 plus, and if we expand we get what, 2 over 2 1 plus I, and it becomes 3 over 2 plus I and a half. And the next and another with minus, so it's minus 1 minus I, and it's what, negative a half minus I multiplied by 3 over 2. You may check, and you may consider all 4 variants, and you will see that there are only 2 different solutions, because other 2 will be the same as these 2. Let's check. 3 plus, correct. And the next if z is cosine plus I sine, show z to the power n plus 1 over z to the power n is 2 cosine of n theta. Definitely a complex number to some power, we should use what? The Mohr theorem, and it says that z to the power of n, it's in general modulus to the power n cosine of n theta plus I times sine of n theta. And since we need z to the power of n plus 1 over z to the power n, and which is z to the power n plus z to the power of negative n, and z to the power of negative n, we just substitute negative n for n and get cosine of negative n theta plus I sine of negative n theta, and it becomes our modulus is 1 here, so it becomes cosine of n theta plus I sine of n theta and plus cosine is even function, and cosine, or let's rewrite, cosine of negative angle is equal to cosine of a positive angle, plus I sine of negative n theta, and sine is odd function, so it becomes cosine of n theta plus I sine of n theta plus cosine of n theta is because cosine is even function and sine is odd function, and function of negative x is equal to negative function of x, so it's minus I sine of n theta, and you can see sine cancels and we get 2 times cosine of n theta as required. And then given that each of the 4 roots of the equation has a modulus equal to 1, find these roots, and definitely hence we should use the previous result. And you can notice that you can see 5, 5, 11, 11, and if we divide each term by z squared, z squared, z squared, z squared, z squared, z squared, you can see that we get that it becomes 5, and let factor out 5, we get 5 z squared plus 1 over z squared, and minus 11 and z plus 1 over z, minus 11 z plus 1 over z, and just plus 16. And using the previous result, we get that it's 5, and it's times 2 cosine of 2 theta, minus 11 times 2 times cosine of theta, and plus 16 is equal to 0. And we can see that 2 theta is double angle with respect to theta, and we know formula that cosine of 2 theta is what? Cosine squared minus sine squared, or 2 cosine squared minus 1, to get this equation in terms of cosine only. So it becomes, and you can see that we can divide each term by 2 to get 5, and cosine of 2 theta is 2 cosine squared minus 1 minus 11 times cosine of theta plus 8 is equal to 0, and it becomes 10 cosine squared minus 5 minus 11 times cosine plus 8 is 0, and we get that we get quadratic 10 cosine squared minus 11 cosine plus plus 3 is equal to 0, and discriminant is b squared 121 minus 4 raised c. It's what? It's just 1, and solutions are cosine is minus b plus minus root of d over 2a. So when minus, it's what? It's a half, and so cosine is a half when minus, or cosine it's what, 12 over 20, or we divide by 4, we get 3 over 4. Sorry, 3 over 5. 3 over 5. 3 over 5. And if we know cosine, we can find using main trigonometric identity, sine squared plus cosine squared is 1. Hence, for this root, sine squared is what? 1 minus 1 over 4, and it's what? 3 over 4. 3 over 4. Hence, sine is plus minus root 3 over 2. And here, sine squared is 1 minus 9 over 25, which is what? 16 over 25. So sine is plus minus 4 over 5. And we get that there are 4 possible roots, and actually what do we need? We need roots, and roots are in the form. It's in this form. It's because it is given that modulus is 1, and in modulus argument form it becomes like this. And for each cosine we get 2 possible sine values, hence we get 4 roots in total as required. Hence our roots are z1, 2 are a half plus minus root 3 over 2i, and z3, 4 are (3 over 5) plus minus 4 over 5i, because that it's cosine plus I sine. If you know the values of cosine and sine, it automatically becomes the Cartesian form like this. And that's all for this question.